Good morning to this talk, and welcome. So this talk is all about supercharging your debugging in Visual Studio 2017. I'm going to show you some tips and tricks for both C# and C++ that will make you more productive as a developer. So for everyone here, there should be something new today. You should learn something new about Visual Studio, whether you picked it up for the first time this morning, or if you've been using it for the last 21 years since Interdev in '97. And if for any reason you don't learn anything new, I have some jammy dodges that you can pick up. Anyone tried these? They're wonderful stuff. I want them all. So I'm very incentivized to make sure you all learn something new today. Plus, there's only a dozen of them, so I don't know if that's enough. So yeah, so with that, I'm Andy Sterland. I'm the lead program manager on the team that builds the Visual Studio Diagnostics tools. So you might have seen the debugger, the profiler, IntelliTrace, and that diagnostic tool window. My team works on all those features. Now, who wants to see slides? Anyone want to see some more slides? No? Well, that's good, because I haven't got any more. So let's switch over to my machine. All right. So this is Visual Studio. All the features today are out in the public 15.7. Some of them have actually been in there since some of you are probably born even. But there's a lot of features in Visual Studio, an awful lot. Well, maybe not, but I'm not judging. So the first feature I want to show you, I've got a really straightforward app here. It's an ASP.NET MVC app, core in the front end, and it also has a REST service backend. The app is terrible. If you see code up here, keep in mind, I'm trying to show bugs, and I'm trying to show the tools, so don't copy it. It is the worst. It's using, anyway. So the first tip I want to show you is that if you have a project like this, where you have multiple applications that need to work together, so perhaps you have a front end and a REST API, you can launch that, both of them together. So in Visual Studio, if you go to the Solution Explorer and Properties, and you choose this multiple startup projects, for each of the projects in your solution, you can choose if you want to launch it when you press F5. So that's handy if you have multiple solutions. If you're working in the modern stuff like containers and things, it also works for those. So just any number of projects. So that was the first tip. Now the next tip, who uses F5 to launch? Okay, did you know you can also use F10? So what F10 does is it launches your application, and it stops on the first line of user code, assuming you've got just my code turned on, obviously. So I've just launched this application, and since it's a web MVC, I'm in main. Of course, depending on your application type, will depend where you land. And this works for C++, managed code, and pretty much everything. So if you ever want to debug the startup path, just press F10, or perhaps you want to configure your window layout before you hit a breakpoint or stuff like that. So let's actually show you this application working. So like I said, it's a ASP.NET MVC app. It's a recipes book. It's a really small recipes book. The best feature of it, to be honest, is it doesn't have adverts. So you can see there's a few recipes here, and you can do things like search, which will become relevant later on. So let's search for tofu for argument. OK, so we've got no match of tofu. So Guy Fieri is upset. But let's go back to Visual Studio and start to look at some issues. So the first feature I'm going to show you, probably quite a few might have seen this one, is run to. So let's set a breakpoint. And then let's go back a second. And so, of course, we've hit this breakpoint. And for the sake of argument, let's say I don't want to steal this code. Like, I'm pretty sure this code's going to work. There's a lot of complexity here. I just want to skip over it. Of course, one of the things I can do is I could, step, 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 step. But better yet, you can use a feature called run to. So you can go right-click menu, and you can see there's a run to cursor, which will just take you to that location. The other feature that's new and a bit more subtle is for people who like pointing and clicking debugging, is this little green arrow, and what that will do is just run the application to that point. So if you just want to see what the result of something is, and you just want to skip over all that middle code, this is perfect for that scenario. So let's zoom back out for a second. And so that's run to cursor or run to click. Now, let's pretend that I actually want to go back to the start of this function and rerun some code. So some of you might be familiar already. You can drag the statement pointer. So this yellow arrow, for folk new to Visual Studio, is showing you what's going to execute next. And in C# and a few other languages, you can decide what happens next. So kind of like a choose-your-own-adventure game, like why let the program choose? This obviously has side effects in the sense that you can put that instruction pointer somewhere that would make no logical sense. And of course, the application is going to behave funny. But if you're super confident in your application like I am, what you can do is just, rather than rerunning your application, to go through the same code again, I can just set my statement back here. Again, I can drag the cursor, which is a bit awkward for so many lines, or I can use the set next statement, which is just here, or for those of you who like to use mice, you can hold down the control key and use this. So like a set next statement. So if you see these green arrows, that's run to, and control modifies it to set next statement. So it's a bit more accessible, because there's just, it's so easy to find stuff in this menu. So for the next demo, let's set the next breakpoint. Nope, that's not that. Task list. So let's set the breakpoint here and run. Okay, so on this line of code, I've clearly got multiple statements that can execute. And say you probably had code like this too, where you've either chained things together or nested things, however. And let's say you want to go to one of those. So I want to go into get random. So anyone got a clue what combination of step-ins I would need to get to that? It's a bit tricky. One thing you might do today is you might go to definition, set breakpoint, but there's a feature in Visual Studio that works for this exact purpose. You just right-click on the thing. Again, lots of stuff in the right-click menu. It's worth clicking around for fun. So there's this feature called step into specific. And so what this does is you can see a list of all the potential step-in targets. So at this statement, what can I step into? And you can choose from the list. So if ever you have like a chain function, multiple statements on a line, you don't want the hassle of figuring out where to set a breakpoint and managing breakpoints, step into specific. So I can just go straight to the random method, which is this one here. Ta-dum. Okay, so that was a few features around execution control, just showing you how to change where your application stopped. One other thing, let's go and set a trace point. Does anyone use trace points or heard of them? Only 3 people, okay. Well, lots more people should have heard of this feature. So who's ever done debug.writeLine or trace or anything like that? A few more people, like 5 times as many people. So there's a feature built into Visual Studio that fills that exact purpose. So sometimes you don't want to stop your application. You don't want to break. You want to just see like a list of what's going on because it might be easier to read. So this is where a feature called trace points come in. And you can set a trace point 2 ways. One, you can do it off the, there's an insert trace point. Let me just go to the right code, except I've already got it enabled, so let me hide that. Get rid of that. There we go. So breakpoint, insert trace point. And if you've seen this before, you can also just insert a regular breakpoint. And when you insert a regular breakpoint, this very cryptic little gear icon here, that gives you essentially a bunch of settings you can apply. So rather than breaking, you can of course choose an action, which is to log a message. And in here, you can log, there's a few variables that are provided for free. For example, the name of the function, which is cunningly called function. But of course, you can bind to any objects that are in scope. So you can say let's get the count of objects. You can do response. .data. You still have to type correctly, of course. Count and matches. All right. So let's run that. And then I think this was a search, so let's type tofu again. Still no results for tofu. And so the application hasn't stopped, but if you go over to the output window, now I'm using App Insight, so there's a few other things in here, but you can see here, perhaps, let me zoom in, that the name of the function, so that dollar function got resolved to the name of the function, including its assembly, and of course 0 matches, because there's no tofu. So trace points, really quick and easy way to instrument your application rather than using debug.writeLine. It doesn't require redeployment or anything. You can enable them, disable them, and manage them just like breakpoints. So let's unzoom that. So that was a few things about in C#, controlling where you are in your code and where you want to go. So next, let's look at some inspection tips. I'm gonna have a sip of water. Yeah, let's set a breakpoint here. So let's go back to this getRandom function for a second. Now, I'm sure you've all used data tips, which is when you hover over variables, you get to see these little fly out things. Some of you might be familiar with the watches window, and let's clear that before I give away all the prizes. Who uses watches, the watch window? Okay, almost everyone, wow. So one of the things you might have noticed about the watch window is when you type in an expression, we evaluate that. We essentially execute that expression and give you the result. So if you take something really simple, like I've got is this the right, oh, I set that breakpoint in the wrong location. That wouldn't make any sense. Let me just go to the right location. Oh no, I hit the previous one. No, I should have cleaned up my breakpoints after me. Okay, so here we are in the right location finally. And let's step. And so what we've got is a couple of variables here. And let's say you want to see the value of index. So obviously you can type index. And what that do is, of course, going to return the value. Nothing too surprising there, but let's pretend that I was executing something that had a side effect, like it changed the state of your application. So in this case, we're going to pretend for a second that I can't do math very well. I'm not too sure what will happen if I do ++ index. So of course, that increments the value to 7. Now that's actually changed the value in the application. So now, if I was to continue, the result of this function would be different because I was debugging, which is not really what you want. Like in general, you want to kind of avoid issues that are only calls when you're debugging. So this is a simple example, but you can imagine if you're like invoking a function that does work, that it also happens. So one way to avoid this is to use something called a format specifier, which is a fancy word that says after you press comma, so let me zoom in so everyone can see this, you can type a cryptic sequence called NSE, which means no side effects. So when I evaluate this, you'll get the result back, which is 7 + 1 is 8, obviously. But critically, you'll notice that the value of index is still the same. So if ever you have a situation where you're trying to look at an expression and it's going to do something to your application, like change the state of your application, try using NSE. What it does is it'll execute that expression in a virtual, how should we say, like a virtual environment, and won't write data back to your process. So in perhaps, plussing 1 isn't the most difficult thing, but it illustrates the point. And another thing you might have noticed when you're using watches is that values get grayed out occasionally. And one of the reasons they get grayed out, and they have this little refresh button, is firstly, grayed out means it's stale, like this value might not be right anymore. But we do that because we think that executing this will change your program. Because keep in mind, every time you step, we execute your watches. So of course, if you're stepping and you're tracking a counter in some crazy way, you're going to step, you're going to increment it twice or something. If you're really brave, you can change this behavior with complete disregard and just do AC or always call. And then as you step, what will happen is it will always execute. And so you see the refresh button's gone away now. So if you have some code and you're pretty confident and you're just fed up of pressing the refresh button, try this, but do keep in mind it's having side effects on your application. So that's no side effects and always call. And there's a few more of those format specifiers. In fact, I think I've got a screenshot of the documentation. Well, I don't think, I know I have. So I've got links later in the slide that will point to this. There's a few others, mostly for viewing things like decimals as hex and things like that. And some of them are even on the shortcut menu. But let's go back to code. So the next one we'll look at is return value. So let's set a breakpoint here, continue. Hope we hit it, yep, and skip the properties thing, you see that. So yeah, so here I've obviously got a function that's step over it. So again, I've got another one of these chain functions where there's multiple things executing. And say, you can imagine this almost like a pipeline. The string comes in, gets to lowered, gets uppered, and trimmed. But if I was to visualize that and see the return of each one, like pretend I want to look at like, hey, what did my toUpper function return? Normally you'd have to step through and try to figure that out. But if you go to the locals window, you can see here in the top, we put the return values with the name of the function straight away. So by default, if a function is executed and you've like stepped through it or stepped over it, you can see the results. So quite clearly I can see what toUpper did, what toLower did, etc. And for as many of those as you have. Another way you can use this is something that's called a pseudo variable. You might have seen this for $exception, but you can do return value, and that will show you the last return value. And that's obviously the same as what's in the locals, but the nice thing here is you can use you can invoke, so you can go 2 lower, etc., and so you can interact with it. And that also works for older values. So if you do return value 1, let's zoom in on that, you can see it returns, ooh, wow, mouse. You can see it returns the previous one, and that's like 1, 2, 3, keep going. So you can see the previous returned values from your application. Okay, so the next one, while we're here, so I'd imagine pretty much everyone uses collections, right? Arrays, lists, dictionaries, stuff like that. And you've all seen this wonderful view where you just get the name of the type. It's fantastic. Like, I want to find the chow pork bun or whatever in here, and I'm going to go for each one of these and try to find it. Good luck. So it's really tricky, but there is something that you can do to make this a little bit easier. What you can do is add an attribute to your classes called debugger display. So by default, let's save and run. By default, when you see a value displayed in the debugger, we try to figure out what to show. We'll do things like we'll call toString if necessary, and the fallback is just show the type name. So many .NET like built-in types have type visualizers for everything from like data sets to bools and stuff. But of course, for yours, there's none. So often you'll just see the type name, which is a real pain. So what you can do, if I go back to this, is you add this attribute, and then you pass in a string. It uses the same format that you saw in trace points, and it can use the properties that are a part of this object. So in this case, curly brace, because I want to bind it to an object, title, and format specifier, enq. So that's no quotes. So obviously, by default in the watch in Visual Studio, we show strings with quotes, because why not? Well, it helps you with the escape sequencing. But in this case, I don't want to show it, so just do enq. And then lastly, I'm showing the ID. So when I look at this now, if I find out where I am, let's get to the call stack. Yeah, there we go. No, actually, it's not that one. Let's run. Did I run too far? No. Okay. Oh, yeah. Sorry. Let's run this again, get to the right place. Here we are. So now what you see is the title name and the ID. Like, so yeah, like if this is one thing you take away from this talk, this is super useful. It takes like 30 seconds to annotate an attribute. You might be asking like, hey, why don't you just use the toString implementation? We will call it a toString implementation, but the downside, of course, is toString is going to be used by your application when you convert objects to strings. And you might want a different textual representation to show, I don't know, bound to an object in a display or something like that than what you want when you're debugging. And there's a whole bunch more attributes. You can decide when things are hidden, when they're shown. You can even suggest custom visualizers and stuff like that. But that's a bit much for a 5-minute demo. So yeah, super easy way to see return collections. All right, so next demo. Let me remember where I am. Yeah, we've done that. OK, so for the next one, I'm going to stop looking at this application for a second and look at a different application that's even more crazy than this one. So this application is a simple C# console app. Again, it exists purely to show a feature in the tools. So for this application, what I've got, if I quickly look to the program, is I've got a program which has a bunch of randomly generated entities that all have an age less than 100. And so if I run it, I just output the count of these people to the console. So it's like, hey, there's a number of people, no one under 100. But all of a sudden, what you can see is there's one person over 100. So something's changed in the application to cause the value to be different. I'm sure you've all had problems in the past where you're trying to understand, hey, this value makes no sense. Who changed this? Like if you're a C++ developer, you have a great feature called data breakpoints, where at the hardware level even, you can look at when values change. That's not, unfortunately, applicable to managed developers, but what you can do is something a bit crazy. So this is so the first thing you might want to try is you might want to set, if you go to the implementation of this class, we've got a getter. So you might want to go ahead, a setter. You might want to go ahead and set the setter. You know, it's just like, hey, someone's changing this, no problem. I'll add a dummy setter. I'll set a breakpoint, and I'll see every time someone changes this object. The downside, of course, is you're seeing it every time someone changes it, which could be hundreds of times across hundreds of objects. So that's a real pain. So what you can do instead, especially if it's just, as in this case, one object, what you'll want to do is you'll find the case that's relevant. So you're looking at the object. So in this case, let's go to the watch window, clear out this, because who knows what that is. Find the current, I think it's person. So this guy called John Smith. So we're interested in one like John Smith has changed. But he's got a pretty generic name, surprisingly enough. So I can't just do like a conditional breakpoint on his name, because that's too generic. But what I can do is I can do this thing called make object ID. So if you've not seen make object ID, it's essentially a way of creating a weak map, so a reference. So now I can look at John Smith by doing $1. And I can do that even when the object's out of scope. We've kind of pinned the object. We've got a weak map on it, so obviously if it's collected, this won't work. But now, the powerful thing is I can go ahead, I can change what was just a breakpoint in the setter that would break every time, as soon as I find the setter, into a conditional breakpoint using this menu, and I can say when this equals number 1. So you can say like, hey, when this object is being set, now break. So the idea here is, of course, that like, while we don't have data breakpoints and stuff like that would break on an object change, if you have a getter, you can kind of hack up something that would work, that would save you from stepping or continuing through a lot of other things. So let's hope this works. Let's close this and run the application still. And remove this breakpoint because it's going to hit 100 more times. Oh, curse it, did I miss it? So yeah, like we can try this again, but like try that next time you're trying to find out which object has changed. You can do make object ID $1, and then you can use that in conditions as well as other places in your application. Oh, hey, it did work after all. So yeah, and now, of course, we can see in the call stack where it's changed. So now we have like, hey, we're stopped at the point the object's being changed, and we can see who did it. Unsurprisingly enough, in this awesome app, I've got a function called cause chaos, which perhaps I should have looked at in the first place. But you get the idea. You can easily find, like if you've got a complicated application, many components written over many years, it can be hard to keep track of who's mutating state. So this is a bit of a hack, but it works. So that's what matters. So we can just continue from that and finish this application. Yeah, we're not interested anymore. All right, so that was C#. We're going to change gears again and look at C++. So hands up here, who developed C++ at all? A good chunk of you. How many of you have to deal with Win32 at all? Hey, so everyone who has their hand down, look to the people who used to have their hand up and feel sorry for them. You have fortunate enough not to have to debug a really painful API set. But for a second, put yourselves in their shoes. So I've got this wonderful application. Let me just run it. Yes, thank you for reminding me. It is quite literally the default template for a Win32 application. You can see we're going to make a lot of money selling this. But the first thing I want to do is add a help about link, because old apps love help about. But this one's going to be fancy, and it's going to launch the browser. Except if I do it, it doesn't. Instead, it brings up Windows Explorer. Not at all what I was expecting, and there's no errors, no exceptions, nothing. Strange. So let's go ahead and try that again with the breakpoint this time. And let's close this. You don't care about these right now. So the first thing you'll notice, we're in essentially what is the event loop for an old Windows application. And we have all these cryptic values. So very briefly, the way it works, you get a message which tells you what sort of operation is going to happen, like a paint or a read size and stuff like that. And all of these are contained in these lovely like WM command and stuff. But it can be tricky to know what they are, because of course, if you look at them in a watch, what you get is just that, it's 273. Like, who knows what 273 is? You got to go look that up on the internet, right? And good luck searching for 273 on the internet. But of course, if you do a format specifier of comma WN, we'll translate that into the window message. So you can say, oh, it's WM paint. Of course, I'm painting. Who would have known? So let me just zoom out, because that's enough of that one. So it helps you take some of those cryptic things out of the old school C++, and let's just keep stepping. So another challenge you might have come across is that here you can see I tried to get an environment variable. It seemed to work. Granted, I'm not checking for it, which is pretty silly. Keep in mind that this sort of API, what it does is it returns 0 for success and then a whole range of numbers for when it doesn't work. And the challenge is unlike .NET, is that you have to get the error code from somewhere else. You have to call an API to see what the error result was. I can't do that right now because my app's running. But over in the locals, the watch window, I can do that. And if I just add $ERR, again, this is a pseudo variable, so it doesn't exist in real life, but we've called that API under the hoods to get the last error. And again, you can see it's another cryptic number, 203. Anyone got a clue what 203 is? I sure as hell haven't. But if you do, this time, it's a H result, so you can use this. You use a format specifier of HR, and it tells you, environment variable not found. Wow, is that like 1,000 times more informative than 203? So again, like, really quick and easy way to get at the actual underlying, how should we say, human-readable message, rather than the pound-defined message. And in this particular case, because this app is just so amazing, we're using the URI and we're stuffing it in the environment variable block, which is pretty brave. But one thing you can do, if you ever use environment variables, you can look at them in $env. And so obviously, like, your application environment variables will inherit from the system, its parent processes, and anything else you set. So there's not really a great place to look at them in C++. But with this, you can do $env, and you can do the text visualizer. And if I look, what I can see is a whole bunch of environment variables. But the one for me is this one here. And I've done crazy place for a URI, and of course, I've managed to mistype that. So pretty easy fix, but really just exists to show a few features for C++ developers when you have to unfortunately deal with some of this. Okay. So that was C++. What next? No, let me stop this, sorry. All right, so let's go back to the recipes app and just change it around a little bit. We're just going to debug just the MVC app now. I want to show you some other features. So, start without debugging. Okay, now launch it. All right, so who so far has seen something new? Okay, that's pretty good. Not everybody, though. That's not so good. Okay, we didn't actually want to debug this, so let's just continue for a second. Yep, let's get to application. Okay, we got it working, yay. So let's put the diagnostic tools window while we're here. Who's heard of snapshots? Okay, a few of you. So it's a new feature we had in Enterprise. And actually, I forgot to do something first. So we've worked on this feature called snapshots. The way you can think of it is it's a picture of your application taken at a point in time. So if you're familiar with dumps, similar sort of concept, except we don't take, we don't stop your process to take these. What we do under the hoods is we essentially fork your process, and then you have a copy of it that we can attach to and debug, and you can access your data. So the value of this, you might be thinking, well, that sounds technical, but why do I ever care about that? The value in it is that you can see your application back in previous points of execution. So this is useful if you're local debugging, because it allows you to go back to a previous point. But it's also useful in scenarios where you've deployed, and you've got something running in the app in the cloud, and you don't want to stop your running application. Now, we have a whole set of features that I don't know if we'll have time to demo around the snapshot debugger that help developers, when you have a deployed application and you can't just remote debug your web server because, of course, you're going to stop it every time you hit a breakpoint. So I'm going to show you snapshots now. It's a part of IntelliTrace. So how many people here have VS Enterprise? Okay, a good chunk of the audience, so this is relevant for you. This is one of the reasons you would buy Enterprise, which comes with IntelliTrace. So the first thing you need to do is you need to enable it. So this is the IntelliTrace options pane, and here you can choose IntelliTrace events and snapshots. So IntelliTrace has 3 modes, if you're not familiar with it. One is essentially events. So in the diagnostic tools window you see on the right, most of you might close. Yeah, some of you. That shows you like the events that are coming from application. It doesn't capture any data. It's basically like a for free trace logging system that we have. The next level of IntelliTrace is that once some events happen, we take a snapshot. We take that picture of your application and allow you to debug it. And then lastly, we have this mode, which is always on, essentially capturing every single call, and you can have a much more fine-grained inspection. They each have their trade-offs, but IntelliTrace and snapshots is the sort of thing you can run most of the time. So it has like a fairly low overhead, like I think the 90th percentile is 18 milliseconds for taking a snapshot, something like that. Whereas IntelliTrace events and call information, you'd want to turn on occasionally when you have a very difficult, hard to repro bug, because of course, it has a much higher impact. So we turn on this, and again, we're going to launch. And actually, let's set a breakpoint somewhere. I guess anywhere would do. So yeah, so these things where it says program app output, some of them are IntelliTrace events and some of them are app insights. So for free, like in IntelliTrace, we've instrumented things like the network stack for when you're making SQL calls or web client calls, etc. And then app insights also has some stuff on top. So I think if we refresh this page, we'll hit that breakpoint. And then let's step. Okay, so yeah, so like I've just stepped to my application, and I'm going to step a few more times for the sake of it. And what you might see over here is this little camera icon. So that's telling you you've got a snapshot. And the way that you might want to use this is that if you want to go back and see what the value of recipes is, we have a button here called Step Backward. Zoom in for gratuity. So like it just, as you can imagine, goes back. So I was on this line here. Now we're back to here. So this value is now null, or it's something else down there. And we can step back again through the application, and we can keep going. So the idea is that like, if you've missed something in your application, you can go back to see it. So if ever you've just like stepped over something, you've stepped too fast, you can go back and see where it's at. The other feature that we added for snapshots, let me just continue out of this, is the ability to take a snapshot when an exception happens. So this, basically what happens when an exception happens in the framework, we'll take a snapshot and put it in that, the diagnostic tools window here so you can look at it. And what we do for that is we have like a little circular buffer, if you can imagine, that you go through, and we'll keep like, I think it's 12 of them. But what you can do is you can control that based on memory, if ever you're interested. Again, in the IntelliTrace options. And if you look at advanced, there's some stuff here. So we won't take more than 250 megs, etc. Oh, it's 5 is the default. And so now, if I go to a page that had an error, so let's choose this top recipes button. Okay, so who's seen this page? Or the error page of some kind from the MVC framework? Right, it has the stack. Who's been able to debug an issue just by looking at this page? Anyone? Okay, but it's good in the sense that it tells you at least where the code, the problem is. But what's nicer is if I go over here, and somewhere, if I show exceptions, oh no, I filtered them out, my bad. Let me filter them back in. What we should have, how do we not catch it, is the exception back in Visual Studio. So like, hey, MVC, you've got the request, it's come to you, you've seen the error page, so it's happened already. And you might be like, okay, so great, recipe view model had a problem in line 63. Of course, you can set a breakpoint, rerun the scenario, but you can also just go to the exception window and have a look at the snapshot taken at that exception and see the data that matches to that request. So without you having to rerun your scenario or anything like that. So that snapshot on exceptions, this feature actually is even more powerful when used with a wait. So I'll show you an example of that in yet another program, because we just can't have enough crazy in one program. So set this as a startup project. Yeah, this one. So again, this is some awesome coding. So we've got yet another console app, everyone's favorite demo app. And all it's doing is trying to write dot to the console, and it's using async await. So many people here use await. Okay. The rest of you, yeah. So for those of you who do use await in C#, it's a wonderful, wonderful feature. It's even more wonderful than TypeScript. But one of the challenges with it is that, of course, the framework is doing a lot of stuff under the hood. It has a whole task system and stuff, and it's trying to obfuscate some complexity in the system, which is wonderful for a developer, but the hard challenge is that the more work the framework does, it's harder for you to debug. Because, of course, magic black box, stuff comes in, stuff goes out. What happens? Who knows? So what I can do is run this application, and I'm not going to be horrified to find that it's going to throw an exception. But interestingly enough, when I look at this, so here we are, we're stopped at the exception. So await null reference task, and it's a null exception. But why? Like, if I was going to fix my application, would I fix it here and add a guard on calling the thing? Like, this isn't the kind of problem. This is just where it's become unhandled. So if I want, I can go back and look in the exceptions, and you can see there's this exception. So I'm stopped here. But if I look in this diagnostic tools window and use it kind of like a timeline for my application, which is a useful feature all by itself, I click on this, and I'm taken to here. And so, of course, here, I've called P, which I passed in up here, and P is null. Or should be, at least, else everything's gone horribly wrong. So let's just look at that. So yeah, P is null. So like, what happened, of course, was that with any asynchronous operation, you do something, you stop doing something, and you wait. Your operation, network, whatever happens, and then later on, action is taken on that work. And in this case, the exception becomes unhandled here, but in reality, I need to go back and add some sort of null check here. This is where I should handle the null guard or do whatever I want to do. So this is an example of like really simple example, but I'm sure in a more complicated application, you can also imagine how it's useful. You can go back from where your exception has been unhandled back to the point in time where you actually need to do something and change something in your application, rather than like, I can't do nothing about it here other than catch it, which wouldn't be too handy. Or I could check not to pass in null, but that would be crazy checking every time you call a function. So that's a useful example of like essentially not an inner exception, original exception perhaps, of going to use that, again, using the snapshots feature inside Visual Studio. Okay, so we've got a few ones. Let's just stop debugging this one. I think it's important. All right, so I think that pretty much covers, let me double check, all the demos I had. And I did tell you a bit of a lie at the start. I do, in fact, have more slides, but just a couple in the last few minutes. Let me go back to this. All right. Let's skip through these. Go, computer. No? Yep. Okay. And let's skip to the end. We did these demos. We did these. Yeah, we did these. Yeah, we did those. Yeah, so we've looked at a few things in .NET, in Visual Studio, and in C++ to make your life a bit easier, specifically around like how you can control the execution of your application using run to cursor and step into specific, which is really useful and one of the more hidden features. There's object inspection as well, so no side effects. Again, a lot of these demos are obviously contrived 5 lines of code. That's because if we had to sit here and go for a real bug, we'd probably just get one tip done, as we spent 2 hours explaining a complicated application. Debugger display. So this is probably the biggest takeaway from this, is that when you're adding classes or go back to your application, think about yourself as a developer. What would you want to see and know from looking at a glance about an object, and put that in a display attribute. There's other features in line for debugger display that I didn't cover that are worth checking out. And then lastly, for IntelliTrace, for people using VS Enterprise, ton of value in snapshots to help you look back at the previous state of your application. And that's important just if you're just stepping over things, you want to go back a little bit, and it's even more useful in scenarios where exceptions happen and you're at a later point in your application and you want to go back and see whose fault it really was at the start. And so with that, there's some links to some documentation just to like those pseudo variables, format specifiers, and all that is online. So all our docs also obviously online. Feel free to search. There's tons of information. One of the challenges that we're painfully aware of is there's lots of scattered information, and there's not a great central place, which is something we're definitely working on. My colleague Leslie also has a lab today at 1:15, I believe. On again, it's a hands-on lab, so you walk through some of these things, go through examples. She has some of these tips and some more tips as well. I think you can also take home the PDF from it. And we have a booth, so if you have any questions, Feel free to pop by the booth. It's in the expo hall in the VS area. Any questions on debugging, diagnostics, like profiling, anything in that space, feel free to ask me. And then, yeah, feedback. We really, really, really appreciate your feedback. So you can reach out to us. Obviously, you can file bugs on our stuff, but you can also email us directly. So one of the wonderful things about the debugger in Visual Studio is we support a wide range of targets. If that's people running Linux containers, people running even IoT and stuff, we support those, but like, please give us feedback when things aren't working for you. We'd like to make that work. And of course, if you want to send us happy news, that's also good. Yep, and you can reach out on Twitter to me at Andy Sterland, or of course, you can also email. And with that, I think I'm done, and I have the obligatory last slide of please evaluate. We also really do love your feedback, so please provide it. And then we've just got a couple of minutes to mill around for questions. Thank you for your time.